and thank you very much for joining us for the UCSX with Intersight, the future of compute. The first thing I want to do here today is I want to take you through first the agenda. So the first thing we're going to start talking about is what unified compute system is. So what's UCS and what is UCSX? Then we're going to start moving into what is the new hardware for UCSX? And then what's the new management? So what is Intersight? How is this different from UCS Manager, what you've been using in the past? Now, with that being said, the first thing I want to do here is I want to talk about what unified computing system is. So there's three main concepts here with UCS. The first thing is hardware consolidation. Now, actually, let me bring up this really expensive whiteboarding utility here. And let me clear that out here real quick. So the first thing I want to talk about here is hardware abstraction. So when unified compute system came out, one of the biggest problems that we were seeing was if we had a server, and actually here we go. If I had a server, one of the biggest problems was, let's say that a component failed. So, okay, I have a network interface card. So we have a LAN connection over here to a switch. If this LAN component fails, normally what we would have is what's called port security, right? So port security would be enabled on this switch. And if we replaced this interface for any reason, normally what it would do, it would shut down that port. Another thing is if we had a fiber channel interface. So that was going to, a storage switch, and then over here to a SAN controller where we would have storage. If for any reason we replaced that interface, the problem is that normally that interface was tied directly here to that storage lawn or that storage volume. So if we replace that interface, it would actually break our storage also. So right now, so far, if we replace anything on the LAN or the SAN side, it would actually break our implementation. Another example here is, let's say you have a motherboard. And on that motherboard, we have this thing called a UUID. Now that UUID, it's tied directly to the operating system. The UUID is essentially the home address for that operating system. If for any reason you change that UUID, the operating system will have no idea how to load on this hardware. So if I replace, let's say, my motherboard and I have my operating system on my hard drive, if we replace that UUID, unfortunately, what will end up happening is, it will actually crash that operating system. So this is, this is a major concept here with unified compute system. The problem that we're having right now is the fact that if we change any hardware right now, or any hardware identities, we're going to run into a ton of different problems. So what we did here was Cisco developed this thing called Unified Compute System with a service profile. Excuse me. And now with that service profile, what we're able to do at this point is virtualize each one of these identities. So my UUID, my worldwide node name, my worldwide port name, MAC address, and virtualize that as a identity, as a virtual identity. And now with this virtual identity, we can now move that. And actually here, that's 8 servers, I promise. So we can now move that identity from one server to another. Let's say that, for instance, this motherboard now goes offline, down to the ground, on fire. We can now take that service profile and move that same identity within minutes over to another piece of hardware. That means that now this server is now taking on the identity of the original server. Now, that again, folks, that's a very, very major concept with unified compute system. Another thing is hardware consolidation. Now, what we were seeing back in the day is that we were seeing a lot of hardware sprawl. What we were seeing was if we had a couple of racks here, what we would see is, okay, we have our top of rack system, and then we would see our servers here, right, in each one of our racks. Well, there we go. And then what we would have is we would have our end of row routing system. Now, what the end of row would do is it would take us to our LAN and our SAN architecture. Now, here's the thing. What we were trying to do was we were trying to consolidate the amount of servers that we were seeing here. When you have a server inside of a rack, it was normally plugged into a top of rack and, as I mentioned, an end of row. Now, what we were trying to do was we were trying to consolidate the number of servers and the top of rack system into one consolidated system. Now, with that said, what we did was we came out with the good old 5108 series chassis. Now, with the 5108 series chassis from Cisco, what we were doing was we were essentially taking 6 RU and 8 RU and converting it to 6. If we, and here's the 5108 series chassis, this is a 6 RU racking system, as opposed to what we used to see as 8 RU for each server, and then maybe 2 RU for our top of rack system. Here's the neat part. With the 5108 series chassis, what we did was we also implemented this thing called an input-output module. So now what you could do was consolidate an entire 8 server rack system into a 6 RU system. By the way, of course, we need an end of row. That's end of row, I promise. End of row solution that went to our LAN and SAN. So then Cisco came out with this really neat thing called a fabric interconnect. The fabric interconnect is what we plugged the chassis into that allowed us to get to our LAN and SAN architecture. Now, another thing here with UCS, what we were trying to do here is, again, we were trying to consolidate architecture. So, excuse me, what we would see here in the past is we would see our LAN and SAN architecture here. And then what you would normally see is you would see a LAN and SAN switch here. Now, what we were noticing was when we plug that into our server here, folks, you were having a network card and you were having a fiber channel or storage card. Now, what we noticed was too many switches, too many cables, right? Just there was just too much stuff going on altogether. So when we talk about converged infrastructure, we're actually talking about taking these 2 switches, and by the way, that's our LAN and SAN switch. We're taking those 2 switches and we're combining them together. One moment, please. Now, once we combine those switches together, we can also now have one cable from that switch to my server. And by the way, now that we consolidated the switches and the cables, now we can consolidate these 2 interfaces together into what we call a converged network adapter. Now that CNA card is really, really important, folks, because not only does it do LAN switching, it also does SAN switching, which means that through this one interface, through this one cable, through this one switch, now we can contact our LAN and our SAN without any issues. Now, with that being said, the next part is, what does this normally look like? Traditionally, with a standard UCSX or UCS topology, what we're going to do is we're going to plug our computes, our servers, into our fabric interconnects, and those fabric interconnects are going to connect us to our LAN and SAN topologies. Now, this is really important because traditionally, the fabric interconnects, we had what's called a UCS manager. Now, that UCS manager was what we utilized to manage our server configuration, our LAN, and our SAN configuration. Now, moving forward, we still have our compute system here. We still have our networking system, and we still have our storage system. What's really changing here, folks, is the management from the UCS manager over to the Cisco Intersight dashboard. Now, I will be taking you through a quick rundown of the Cisco Intersight dashboard. And actually, we're going to create a domain profile and a server profile here. But the major point here, folks, is to note that moving forward, we are no longer using that UCS manager on the fabric interconnects. We are now using this Cisco Intersight dashboard. Now, the last thing that I want to talk about here with the unified compute system is server profiles. Server profiles, folks, super, super important. We were talking about how it moves the identity, your UUID, your MAC, your worldwide name, worldwide port name, over to another piece of hardware. But that is not all it does here, folks. It can move, or actually configure, your BIOS, your firmware, software updates. What this really is here, folks, the server profile is, think about all of the stuff that you used to configure before you would install an operating system. Excuse me. A server profile is what we configure before we install an operating system. So that's a really, really key piece about UCS, is the fact that the server profile is building that hardware configuration. And by the way, yeah, BIOS, what about boot order? What about RAID configurations, right? So the server profile builds that hardware configuration for us before we install an operating system. And again, folks, that's called a server profile. Now, with that being said, let's go ahead and jump right into the good news stuff here. So the new chassis that you're going to see, this is the X9508 series chassis, and I'm very pleased to introduce you to it. One thing you'll note is, first and foremost, it is one more RU larger than the original UCSX, or I'm sorry, UCS 5108 series chassis. Another thing to note, we still have 8 servers. So instead of them being horizontal, you'll note that they are now vertical. I also do want to mention that they are optical and liquid cooling ready. By the way, I do have a roadmap to show you in just a moment here, so that we know, by 2024, we're looking to have full liquid cooling compute nodes. Now, another thing here is we upgraded from 4 power supplies to actually 6 power supplies. The original was 1500. Now we're looking at 2800 watt power supplies. The original power distribution was actually 12 volt. What we did was we amped that up to 54 volt distribution. And by the way, again, excuse me, again, instead of having those 8 fans in the back, what we're seeing is 4 100 millimeter dual rotor fans, which, by the way, the original fans were 120 millimeter. What we did was we consolidated that down, And I don't have, I don't have enough time to talk about the fantastic power and cooling options here. But let's just say that the four 100 millimeter dual rotor fans here in the back, they're now essentially dedicated to processors. Again, moving forward, we will be looking at liquid cooling in the future, but not as of today. Now, another thing that you'll notice here in the back is that we have our Ethernet fabric modules. So these are what we call our intelligent fabric modules. You might know them by another name, input-output modules. Right, your input-output modules, IOMs, that's exactly the same thing. It's exactly the same thing. But I do want to show you a brand new module here, folks. Now, again, I don't have a lot of time here. So I just want to mention that these two modules, we call them the X fabric modules. And the X fabric modules, what they do is they are a connection to storage controllers, external or tertiary storage controllers for the compute nodes. And get this, GPUs. That's something that we have not had connectivity for here inside the chassis, inside your B series ever, right? We've never had GPUs. What we're going to do now is, and by the way, this should be dropping hopefully mid to late March. We're going to drop the ability to install graphical processor units inside of these XFMs, so that each one of these compute nodes has the ability to talk to GPUs. Now, what's really, really neat about this entire system here, folks, is the fact that, guess what? We're not bogged down by that chassis. That chassis has nothing to do with how we actually connect our physical equipment. So we can see here that I've got 8 servers, but here I've got my 2 input-output modules, or I'm sorry, my intelligent fabric modules, which, by the way, folks, doing the same thing, right? And by the way, we have side A and side B. So you're still maintaining the same architecture as before, but in a more modular design. By the way, again, down here, this is going to be later, for in use for storage and GPU here. So right now, no, we don't have any storage or GPU capability, but as of the end of this month, we will. Now, speaking of the end of the month, timelines and all that jazz. So 2020, 2021, 2022. Right now, we're looking at primarily looking at liquid cooling the GPU, right? So our GPUs inside of the chassis, they should be liquid cooled by at least the end of 2022. Now, by end of 2023, we're looking to also liquid cool our GPUs and our CPUs. Another thing to note here is by 2024, excuse me, we want to also be able to liquid cool our GPUs, CPUs, and our FPGAs. Now, with that being said, that's just it's a soft timeline. We're hoping we can get there. Supply chains and all that jazz, we're hoping we can get there. So by 2024, we're looking at full optical and liquid cooling 9508 series chassis with the X210 series compute node, which is what you guys are looking at and gals are looking at right now. So this is actually, it's kind of a misleading graphic, because if you noted before here, if we go back here really quick, the compute node goes, vertical instead of horizontal. So this is actually much wider than what you would probably consider as a half-width blade server. So with that being said, it's still supporting second and third gen CPUs. We are now supporting, by the way, the 14,000 series VIX, which is the 14,425 and the 14,4, or I'm sorry, 14,845. With that being said, the compute node also supports up to 32 DIMMs. We are also supporting, and don't ask me about the Intel persistent Optane memory. Intel's got a whole thing on that, but we do support 32 DDR DIMMs, up to 16 Optane persistent memory modules. By the way, with that being said, with the Optane memory modules, with the Optane memory modules, not only do we support DDR4, but we're also supporting that brand new, well, I don't want to say brand new, but our NVMe drives, our non-volatile drives here. So by the way, in the front side here, this is a major advancement. What we saw in the past was you had a maximum of 2 hard drives per each one of our B series. Now, as you can see, we have 6. Now, we do have a lot of different options. Again, I don't have a lot of time to talk about them, but we do support 6 SAS and SATA drives here. Or you can actually, we do have a front side mezzanine that will support all 6 NVMe drives as long as you're using the Intel VROC technology to RAID those Intel and NVMe drives together. And then the last thing is, instead of having those good old-fashioned flash drives, which we all love and know, right? I'm not saying they fail, but they fail. What we're doing now is we're doing what's called an M.2 RAID drive. Actually, if we look right here, right in the middle of the motherboard is our M.2 drives. Now, these are solid state drives. By the way, these are those onboard drives that we used to use as like a secondary or tertiary boot sector. Now we're just calling them M.2. They are optional. So you can get 1 or 2 with the optional RAID 1 version for those M.2 drives. Now, the last thing that I want to talk about here on the hardware side, before we get into the fantastic new Intersight management dashboard, is I want to show you what the networking looks like. So if you notice over here on the right hand side, we have our VIC 14425. Now, as you'll see here, these are 25 gig, which means that each one of these KR channels, they're 25 gig. So what we've done is, just like when the 1300 series came out, we bundle these together. So we have 2 25 gig KR channels bundled together, right? So now that's 50 gig, 50 gig. So right now that's an effective throughput of 100 gig just with one 14425 adapter. Now, the next thing is we do have a VIC 14825. Now, I want to harken this back to the good old-fashioned VIC 1240s. If you remember back in the day, a VIC 1240 gave you the ability to open up more KR channels if you install what was called a port expander. We're seeing something very similar here, folks, moving forward with 14825. It is going to open up 2 more KR channels per input-output module. But what's very, very important is it's 2 things. It's utilizing the VIC 14000 series bridge to bridge the communication from the 825 over to, the IOM A and B. But what we're going to see this used more often in the future is we're going to see KR channels back here over to our GPU and our storage controllers. The VIC 14425 is primarily used for networking. What you'll see moving forward is the 14825 It will open up more KR channels, but its primary, focus in life is to actually allow communication from our GPU and our storage controllers up to the compute nodes. Now, with that being said, the last thing I want to talk about here is the new management suite. Now, I did throw this slide out there because I did want you folks to notice this thing right here. Redfish. Redfish is very, very important because it's running underneath the hood on all of our devices. Now you see our C series, our B series, but then our X series. Yeah, Redfish is actually running underneath the hood on our X210 series compute nodes. And it's also running on our VIX, our SIMCs, our chassis management controllers. And what it's doing is it's essentially sending management data back and forth between our compute nodes and our data center, or device connector proxy to what we call an Intersight network agent. Now, folks, if you've ever seen, server client kind of deal, what we're seeing here is that the Intersight network agent, it's acting like a proxy over here to our Intersight Redfish server. So Intersight is really that Redfish server that's pulling in, taking down requests for Redfish in and out. So the major point here, folks, is that what you were used to seeing is the fabric interconnects, they would have this UCS manager implemented. We are no longer using that. When you update to UCS Manager or your Fabric interconnects to 4.2 and later, what you're seeing now is that it installs this Intersight network agent, which allows us to talk to our Redfish connectors. And again, by the way, folks, that Redfish connector is already capable of talking to your B and C series and your new X210 series. Now, with that being said, if you give me just a moment here, I'm going to go on mute. I'm going to bring up my Intersight dashboard. And what I really want to show you here, folks, is what's the new thing with our domain and server profiles. Now, this is very, very important if you're going to do a deployment because, again, we've got our domain and server profiles. We're used to doing service profiles, but what is this whole domain and server profile? So give me one moment here to bring that up and we'll go ahead and show you a demo. Okay, folks. Now, if you go to intersight.com, by the way, I do want to mention here, folks, that this is completely free. If you want to go to intersight.com and you want to start managing your UCS deployment today, you absolutely can. Now, don't get me wrong. There's features and capabilities that are licensed, but for the most part, yes, you can absolutely bring in your servers into this Intersight dashboard and start at least viewing the health and status of each one of your UCS components today. So what I'm doing here is I'm popping into intersight.com here real quick. And what I wanted to show you is the first thing is targets. Now, what we're used to seeing is in the past, what we would do is we would connect to our Fabric interconnects and we would manage those Fabric interconnects alongside the UCS manager. Now, with that being said, we don't do that anymore. What I did was I updated my UCS manager here or I'm sorry, my fabric interconnects. One moment. I actually updated those fabric interconnects to the 4.2. So now if I connect to those fabric interconnects, what you'll notice is now I don't get a UCS manager. I actually get a device console. Now, this device console is very different than what we're used to seeing because it allows me now to connect that redfish connector here to my Intersight dashboard. So if I go over here to claim a new dashboard, or I'm sorry, a new UCS domain, I'm going to select Intersight Managed. I'm going to go ahead and pop in that device ID. And, oh, one moment here. Logged into the wrong account. Give me 1 second here, folks. Gotta love live demos. Here we go. What it's going to allow me to do is utilize that device ID and claim code to now bring in or claim my fabric interconnects here. So as you'll see here, when I say targets, you'll see our fabric interconnects. So now what we're seeing here, folks, is the communication path between the fabric interconnects and the redfish connector here at the Intersight dashboard. And by the way, just real quick, I did want to go over profiles here. We have 2 major profiles now. I'm sure you're used to creating a service profile. By the way, they're now called server profiles. And by the way, we didn't reinvent the wheel. You know what? I'm going to go ahead and just name this John Test. Okay, cool. So we're going to say next. Where do we want to, right now, I don't have any servers, but I could assign to a server just like before with our UUID. If you remember that first interface, or I'm sorry, that first selection here, you'll notice you can assign the server. We can do our compute configuration management, storage, networking. So if I say assign later here and go next, you'll notice that the compute configuration is all about how do we configure the server itself. If we go to management, this is all the stuff that you're used to seeing, right? NTP, SNMP, SSH, syslog, IPMI, right? LDAP configs, right? These are all of the configurations that you're used to seeing for management. Oh, let me go back here really quick. Our storage configuration, this is where we're going to configure our M.2s or our RAID configuration. And then last but not least, if you remember building your LAN and SAN configuration, so we do see that we can create here my LAN interfaces and my SAN interfaces. So if you're wondering where you create your VNICs and your VHBAs, it's right here, folks. Now, when I click next, this is where I can now deploy or assign the server profile. Now, I'm pretty sure if you've utilized UCSX or UCS in the past, I'm pretty sure that seems totally normal. But the last thing that I wanted to show you here is the domain profile. The domain profile is very important to me because here's the thing, folks. We used to configure our fabric interconnects individually, and then we'd go to individual ports and we configure those. Here's the thing. We would be also configuring VLANs and vSANs, unified ports, tons of stuff. And that was up to us as UCS admins and specialists to know where to go during that initial deployment. what I absolutely love about the Unified Compute System X is now we have this thing called a domain profile that allows me to create a configuration for the fabric interconnects. So as you'll see here, I can assign that to my fabric interconnects here, right? So that's my Cisco lab, my 6454s. I can go ahead and, well, we'll assign that later because it's already assigned. Then I can assign my VLAN and vSAN configs. I can then, let's go over here. Okay. With our interface configuration, I can configure my server ports, my uplink ports, my storage ports, and oh, by the way, yeah, we can convert our Ethernet ports to fiber channel. It's a little different these days, but you know, nothing too shocking. And then the last thing that I wanted to show you here, folks, is the management configuration. So we have our NTP, syslog, SNMP, and our network configuration. By the way, this is a global system QoS configuration, and the switch control policy, that's more for things like max, here we go, max MAC aging time. Not something that we generally, we generally mess with. But with that being said, after that, you hit summary. When you click deploy here, it's going to deploy all of this configuration over to your fabric interconnects. And if you folks have no questions, thank you very much for joining us here for the UCSX Tech Talk. It was an absolute pleasure, and hope to see you at the end of March.